So for lesson 6, we're coming back to those two warm-up problems where we were finding, what's 30% of 40 and so on. We're dealing with percent of change. We start off pretty basic. If we look at example 1, we want to change each of the following to a percent. We have our old rule that we used in the elementary days is that we move the percentage points, the decimal place 2 places, and do we move them to the right or to the left? Right. Okay. So 3.5%. The other thing that we're doing here is when we convert a decimal to a percentage is we're multiplying by that 100 that we talked about in the lesson. 4, if we convert that to a percent, a lot of people are going to say, okay, we need to move it to the left just because we're used to looking at it that way. But understand the rule. Again, we go to the right. 4 is equivalent to 400%. 1/8. What's that?
12.5%.
Yeah, because we know that if we take our calculator, it's 0.125, and now we go back to problems A and B, move it 2 places, 12.5%. 12 over 5. Yeah, what is it as a decimal?
Like
2.4.
4.
2 places to the right. And the only other comment that I'll make on it is notice anytime we're dealing with a number that is less than 1, we are dealing with a percentage that is less than 100. And as soon as we climb above 1, we now are dealing with a percentage that is greater than 100. Use that to your advantage to make sure you are right. Nice little warm up there. Percent of change. We do have a formula for this. It is the amount of increase or decrease. We can go either way. Divided by the original amount. Or the regular amount. So again, percent of change is the amount of increase or decrease. That's the difference between the two values. And then we're going to divide by the original. For example 2, it's pretty straightforward. We want to calculate the percent of change and then determine whether it was an increase or a decrease. Do we get bigger or smaller? So for A, we're going from 120 to 168. So I think that pretty much answers the second part of the question. Was it an increase or a decrease? Well, it was obviously an increase. So we'll keep that in mind. Let's go ahead and calculate that actual percent of change. Now again, the formula tells us that it is the amount of increase or decrease. So what we want to do is we want to find the difference first. The difference between 168 and 120. And I would always just put the bigger number first, that way you stay away from the negatives. Difference between those two is 48. And that's going to be our numerator. What's the original amount? Yeah, it's the beginning amount, 120. We take 48 divided by 120. Decimal is 0.4. Convert that to our percentage, 40%. And again, identify, did we increase or decrease? Well, we increased. On your own, percent of change when we go from 6 to 5.1. The amount of increase or decrease, the difference again is 0.9. What was the original amount? 0.9 divided by 6. Calculator will handle that for us. 0.15. Increase or decrease? Decrease. And then we get into problems like number 3. Same concept, just kind of a different way of viewing it. Okay, different parts that they're given to us. What is the new amount when 58 is decreased by 70%? What is the new amount when 58 is decreased by 70%? There's 2 methods that we can use here. Method number 1, I consider it to be the 2-step method. What's the first thing we want to do here? What did you do, Abby?
I found 70% of 58.
Yeah, so you ended up taking the 58 times 70%, which is equivalent to the 0.7, right? And that's what you want to do. Take the amount times the percentage, convert it to a decimal, and the number that we come up with there is 40.6. That was step 1. What do we do in step 2 now?
Track that.
Yeah, we want to subtract it from the original amount because we knew that 70% of 58 is that 40. Subtract it from the original. And it makes sense that it should be about 17.4. You know, if we're going to decrease by 70%, we're taking a large portion of that away. 10 students in the class, we decrease by 70%. We're now down to 3 of us. Method number 2, I just want to bring this to your attention because this is how the ultimate method that we teach it in Math 8. You guys remember this percent of change box? We have 2 columns. We have the percent and then the amount. Over on the left-hand side, we had the original amount, the change, and the new. Coming back to us yet? Hopefully so. It's crazy how time flies. What was the original percentage always going to be? 100. This is a guarantee. You will put 100 in this box every single time. Guarantee. And now we fill in the other pieces that they give us. They gave us the 58, which is that the original change or new amount? Original. That's your beginning amount. Very good. 70%. Change or new? Change. So what's our new amount? 30. Plus or minus always there for if it's a decrease or an increase. And which one are we solving for? Is it the change or the new? Well, we want to solve for that new amount right there. So, what's the purpose of this? Well, what it does is it actually sets up a proportion for us to solve. We need to solve for x, so we definitely need to use the last row. We are also given these 2 items, so we're going to use the first row. So, the proportion that we set up is 100 over 30 is equal to 50 over x. Calculator at this time, 30 times 58 divided by 100. I'm guessing you came up with 17.4, and it worked. So you can use that method as well. Okay. On your own, what is the new amount when 620 is increased by 350%? You can use either method if whatever you want to use. You know, if you like the percent of change chart, it always works for any of these problems. If you like the two-step method, that's fine too. When you get an answer, just check with a neighbor. (350% as a decimal is equivalent to what? Yes. And what is that amount? Is this my final answer? No. And every year, for 5 years now, 30 to 40% of the students on the first test will give me that answer right there. And I'm like, ooh, you were so close. But we got to go back and do step 2. We need to take that 2,170, and what do we do it with 620? You add to it, because again, it's an increase. Notice the difference up here. It was subtract. Here it's addition because we're increasing that amount. Total amount that you should come up with. Heard you guys say it over here on the right, 2,790. Last two things that we need to take a look at: sale price versus market or markup price. Businesses, whether you're talking bigger businesses like Walmart or Target, or whether you're talking about smaller businesses, maybe like Hometown Market here in town, or Floral Expressions, you name it. Sale price and markup price. Okay. Let's first talk about the sale price. You know, just coming off of Thanksgiving, Black Friday, holiday season, a lot of those items were on sale. Sale price. How do we find it? Well, it is the original amount or the original price, and then we're going to subtract off whatever the discount is. Now, this seems pretty straightforward. The only problem with this formula is more times than not you have to go back and find the discount. So again, it's kind of a two-step problem there. If we wanted to find the markup price, same concept. We are going to take the original price, and now we're going to add whatever the markup is on it. So instead of selling it for $10, maybe we want to make some money and try and sell it for $18 and so forth. The original price of the TV was $170. It is now currently on sale for 20% off. So what is the new sale price going to be? The original template was the original price minus the discount. Problem is, do we know what the actual amount and discount was? No. So that's the first thing we gotta find. On sale for 20% off. How do we find it? Well, we again begin by taking the amount that they give us, 170, and we need to take it times the percentage that it's off. 20% being equivalent to 0.2. Original price that we started with was 170. 170 times 0.2. The discount was 34. Take that off of the original, 136. Does it seem reasonable or logical that it should be that one? Absolutely. 30% off, okay, take off a little bit, not a lot, but 136 is definitely better than 170. So for that example, you were the customer. When we talk about markup, now you are the business owner. We have to make some money when we sell these items, so we are going to mark up these items that we are trying to sell. Here we're trying to sell some candles at a local candle maker, or from a local candle maker that charges $3.15 for each of them. And what we want to do is turn around and sell them at a 400% markup. So we're going to buy them at $3.50 each. We want to turn around and sell them for 400% markup. We were told by our financial advisor if we're going to actually make some money with this thing, your markup needs to be $400 or 400%. We need to know what price tag are we putting on those candles. Template again. It was the original plus the markup. The original price we know, that's the $3.15. What we need to find is that markup amount, which again is the same concept. $3.15 times that 400%. 400% as a decimal would be strictly 4. 3.15 times the 4. 12.60. So the total price that we are asking for those candles now are $15.75. We hope they are really good candles. Or you get my wife to walk into your store because chances are she's going to buy it too.
Yes. On markups, could you always add 100